This is Mr. Peterson, and I'm continuing the notes for section 1.3. This is the third page in that note packet for Algebra 2. All right, so we're going to start with breaking up this left side. We get this long division bar here, and we're going to split it up as to m over 3 and negative 6 over 3. So that looks like this, m over 3 minus 6 over 3. You could just put a 2 there if you wanted. I'll get rid of it in a different way in a second. Now, the only denominators, or the denominators in the problem, are both 3's. So to clear that out, I'm going to multiply everything by 3. The first round right here, the 3's would cancel and give m. Once you've done that, the second round, also the 3's cancel, and so you get minus 6. Over here, nothing cancels. You get 3t plus 3w. Okay, we're trying to solve for m, and we've cleared the fractions. Now I need to gather everything with m on one side on all the terms that don't have m on the other side. Well, this is just about done. That 6 goes over, and that'll do it for us. Okay, there's two problems here, I think just two, that involve motion, and these are kind of tricky, so we're going to take a really measured approach to this. We have Sam is biking for charity. You ought to read the problem. He passes a bus that's going in the opposite direction at 3 times his speed. So 2 hours later, Sam and the bus are 240 miles apart from each other. So how fast is the bus going? These problems give a bad name to math because they're hard to do. That's part of it. But otherwise, the other problem is that they're not that practical outside of a classroom where they're really valuable for teaching, training, okay? So first of all, identify the two things that are moving, and moving objects, if they go at a constant speed, it's rate times time will give distance. So in this case, Sam is on the bike and he's going one direction and the bus is going the other direction. It doesn't tell us what Sam's rate is or the bus's rate, but it does give us a hint. It says the bus, he passes the bus that's going 3 times his speed. So we don't know what Sam's speed is, but we do know the bus is 3 times as quick, or the speed of the bus is 3 times that. It tells us that both the bus and Sam go for 2 hours. And what's going to happen here is we're going to take rate times time to get distance. Rate times time to get distance. 2x times 2, you'll write as 2x. 3x times 2 will be 6x. And then we have this figure to try and get into the game here. So after 2 hours, Sam and the bus are 240 miles apart. So you're trying to visualize this. Here's where Sam's going. And the bus is going exact opposite him. And this 240 figure is the combination of the two. So it's the sum of those two. And I'm going to go ahead and do it as a total line across the bottom. When they total your groceries, they add them. So we're going to total this column here. 2x plus 6x equals 240. Okay, now we're ready to solve for x. It's going to be 8x equals 240. And dividing by 8 tells us that x is 30. The only problem is that's not my answer because it's not the question that's asked. Not the answer. Now, I highlight that because you are so used to in a math classroom of finding x and then you're done. But this one doesn't ask us for Sam's speed. It wants to know the bus speed. So we have to know this one that I circled over here. 3x is 3 times 30, and that'd be 90 miles an hour. So yeah, that bus is probably going to be pulled over, hopefully by a highway patrol pretty quickly. He's booking. All right, so the Williams are moving. There's Don, who leaves at 8 a.m. in a moving truck, and then half an hour later, his wife leaves in the family car. They're going on the same road, and Sandy, who leaves a little later, is going a little faster. So she'll eventually catch up with Don. She does at 2:30. So it's how fast is Sandy going is the question. So we're going to put Dawn and Sandy here are the two moving objects, if you will. Rate times time equals distance. The rate, we don't know what Dawn's speed is, and we don't know what Sandy's speed is, but Sandy's 5 more than Dawn. They're traveling at they have different times. Dawn goes from 8 o'clock until 2:30 when he meets up with his wife, or she catches up to him. And she leaves at 8:30 and gets there at 2:30, which is only 6 hours. Okay, now we're ready to multiply this column times this column to get the distance column. Likewise over here. And that'll take us to 6.5 times x and 6 times x plus 5. And the way this one is set up, both of them start at their home. And there's Dawn. And here's Sandy. And when she catches up to them, they're on the same spot on the road, or they're next to each other, and the distances are equal. Distances are equal. So I'm going to take these, they're equal. That'd take us to 6.5x equals, oops, let me do it right. 6.5x equals 6 times x plus 5. We'll distribute. Right here. Now I'm going to bring this over and subtract it off both sides. Simplify. And divide by 0.5. So now I know x equals 60. Well, I'd say that's the answer, but the question that was asked us is how fast is Sandy driving, and you can see that x is not Sandy's speed, it's Dawn's. So that's how fast Dawn is going, and we simply plug in that information into the expression x plus 5 equals 60 plus 5, and Sandy's going 65 miles an hour. And that's the one that's asked about. Okay, that'll do it for page 3 of the note set. And you can see it says page 11 there. Please ignore that. It might not be page 11 in your copy. All right, we are going to set the stage for the next page next.